In the last couple days, we have done polynomial addition, subtraction, and multiplication. Yes? Would it make sense that division's next? Yeah. So basically we spent 1 day on addition, subtraction, multiplication, and we're going to spend 2 days on division. Does that mean it's harder? No, it does not. It means there's more steps, and I want to make sure that we are confident in it because we're going to use it for more than just one thing, right? Addition, subtraction, multiplication you've done before, right? You're comfortable with that. So that's why we went through it quick, because you were already comfortable, you already got it, right? Division, we want to slow down a little bit, okay? So the first problem that I want to do for you today is actually this problem. Now, does that look like a polynomial? No, it's because it's not. Okay. This is a long division problem, yes? And you know how to do these, don't you? So if I walk you through these steps, would it make sense that long division with polynomials would be similar steps? Okay, so let's do something we already know how to do so that we can do something we haven't seen before and we feel more comfortable with it. Okay, so what goes where? Like, how do I set this up? What do you mean the outside? The outside of what? Oh, the vinculum? So just for the record, I didn't know that till this morning. I mean, I knew there was a name. I don't ever remember the name because I don't care. Right? But I knew there was a name, and earlier they asked me what the name was, and I was like, I don't know, search it up. So they did, and I wrote it down. See, you can see it right up there. I wrote it down so I'd remember it. Because it's a weird word, right? So you're saying the 8 goes on the outside? Like up here? Oh, in the front. Okay. And where does the 5,469 go? Okay. Oh. Sorry for the weird 6. So now what? What do we do? So will A go into 5? No, so we look at like that first part, right? So I divide the first part by the number on the outside, right? So what is 54 divided by 8? I think it would be 6, wouldn't it? Because 7 would be 56, and that's too much, right? So 6, and where does the 6 go? Over the 4. So it has a specific place, right, is what I'm trying to say? Okay, so now what? Oh, first I have to multiply those two, right? And then write it here. 48. And then what do I do with that? I subtract. So what is 54 minus 48? 6. And then what? Just the 6? Could I bring the 9 down also if I wanted to? Yeah. It's just kind of in the way right now, right? Okay. Now what do I do? Oh, so I kind of start over, right? Just like the beginning. I say, how many times does 8 go into 66? 8. Where does it go? So it has a specific place to go, right? And now, multiply, write it here, and then subtract. So 2, and then what? Jot down the 9. And then I start over, right? So 29 divided by 8, 3. What do I do with the 3? Multiply, and then write it there. 24, and then subtract. What is that? Do I do it again? Do I bring some other... if I want decimals and stuff, right? That's kind of the end of my explanation for this problem, because we've gotten to the end of the numbers that are already there, right? I don't want to add anymore to get decimals. You can, and you know how, right? But what is this number right here? That's the remainder, isn't it? So when I'm writing the answer, my answer is 683 and 5/8. Where in the world did I get 5/8? 5 was the remainder. 8 was what I was originally dividing by, right? Any questions? That's the kind of thought process I need you to have when we start polynomial long division, okay? What is step 1? Don't panic, okay? Why do you think people panic right now? It looks messy, okay? Are you ready? You're not going to panic, even if it looks messy, right? Okay, so here we go. X squared plus 5x plus 12 divided by x plus 1. You see why some people panic already? There's a lot of x's and a lot of numbers, and for the record, that's not even a lot, so calm down. Okay, so what do you think goes where? So we have one of these, right? We have a vinculum, and this x plus 1 goes on the outside. What do you think goes on the inside? Now, based on what we just did, is that logical? Yeah, right? It's logical. What we're dividing goes underneath. What we're dividing by goes on the outside, right? Now, some of you are like trying to think about stuff in your head about, okay, how are we going to divide this term by that term and everything like that? It's even easier. This part is even easier than this part because all I look at are the first terms. Only the first terms. I'm almost ignoring this and ignoring this right now. Almost. I just look at the first terms. What is x squared divided by x? So you remember yesterday and the day, or the day before, whenever it was, we said when we multiply like bases, what do we do with the exponents? Add, right? When we're dividing like bases, what do we do with the exponents? Subtract. So remember that there's a 1 here. So what is 2 minus 1? That took entirely too long to answer. You're scaring me. It's 1, right? So x squared divided by x is just x, right? So we look at here and we say x squared divided by x is x. Where do you think it should go? Above the x, right? Above the like term. So just like this problem up here, it has a place, right? Now, if you want to get technical, it does not matter where it goes. But I promise there's a reason. And if you'll just go with me for a second, I think it will make sense. Okay? So do you understand that this is x? Because I took the first term and the first term and divided it and got x, so I wrote it above its like term. You okay with that? Guess what we do now? Multiply. This is why I said we're almost ignoring this term, because we can't ignore it right now. We have to use it. What is x times x? X squared. What is x times 1? What do you think we do now? Subtract. Now, are you going to remember to subtract these two? If I have the subtraction sign right here, are you going to remember to subtract these two? Probably not, right? Because it's way over here. So instead, we're going to subtract both. You okay with that? Now, you guys know I'm a visual learner. We've talked about that several times, okay? But even when I do these problems, I change my sign in a different color than what I'm doing the problem in. Okay? Because if I get to this point and somebody asks me a question, I turn and talk for a second, I come back, am I subtracting? Did I already change the signs? Did I already subtract? If I've changed it in a different color, I already know. Does that make sense? And if there's not a different color there, I know I haven't subtracted yet. Okay? Now, what do I get here? Okay, so here's the thing. If you get anything else besides 0 here, you have done something wrong, because the whole purpose is for us to get 0 right here. Okay, so that's a clue for you right there. This will always be 0 unless you've done something not quite correct. Okay? So this is 0. What's this? 4x. What do you think we should do next? Drop down the 12. Plus 12. And guess what we do now? We start over. First term divided by the first term. What is 4x divided by x? 4, right? Where does it go? Above the 12. What is 4 times x? Oh, let me draw the lines. 4x. What is 4 times 1? 4. What now? Subtract. What's here? 0. What's here? What now? Start over. What's 8 divided by x? Can we divide that? We can't, right? Guys, here's another clue. Where would I put something else if I divided it by something? Is there any more room? There's no more room up here. That's the reason that I start above its like term, right? Because that's going to give me a clue about how many more times I need to divide. There's no more room up here. So I'm probably not going to be able to divide. So what is this number right here? The remainder. And what's this up here called? Don't say answer. Quotient. Okay? This is the quotient. This is the remainder. Yes? So now let's figure out how to write the answer. Okay? X plus 4 plus what? The remainder over what? X plus 1, because that's what I was originally dividing by. That's my answer. Does that make sense? Okay. Can we do another one? Yes? Okay, awesome. I mean, I know I can do another one. I just didn't know if you were already geniuses at long division. No? Oh, not quite? Okay. Almost? Awesome. X cubed plus 5x squared minus 4 divided by x minus 2. Okay, so what goes where? Division sign. Yeah, you can call it a vinculum if you want. It's a division sign, yes? Okay. What goes underneath? But I'm going to tell you, I am trying to trick you right now. So what goes on the inside? Do you see a missing term? It starts with 3, right? My highest exponent is 3, my degree. Then it goes 2. Then what should come next? An x, right? Do we have an x term in our problem? But I need one. What's the only thing I'm allowed to add to a problem that doesn't change its value? 0. So I need to add a 0x. It's just a placeholder, but if you'll give me a couple seconds, I think you'll see why it's important. Is that fair? Okay. So we need our placeholders if there's one. So look for that. Make sure if the degree is 3, the highest exponent is 3, make sure everyone below that is represented. If the highest exponent is 5, make sure you have a 5 and a 4 and a 3 and a 2 and a 1 and a constant. Okay? Otherwise, put in a 0 something. Now, technically, we could have just added a 0 here. Why did I add a 0x? Isn't that still 0? Then you can see it. That's exactly right. You can see the x term. Okay? Everybody okay so far? Okay, so now we start, right? First term, first term. What's x cubed divided by x? X squared, where does it go? So x squared. Now, can I take a timeout? How many more times do you think we might have to divide? 2 more times, because there's 2 more spaces up here. Is it possible that it could be less than that? Yes, but will it be more than that? No. Okay, so multiply. Oh, excuse me, untimeout. Okay, multiply. What is x squared times x? X cubed. What is x squared times negative 2? Negative 2x squared. Now what? Subtract. Uh-oh. So if I'm already subtracting, if I subtract a oh yeah. Guys, do I really want to add a negative negative? No, I know what that means. I know that's going to change it to a positive, right? So is it okay if I just quote unquote subtract by making it a plus? Yeah, okay. What's here? 0. What's here? 7x squared. Now I'll tell you this. Sometimes when I'm doing long division, whatever's left, I bring down. Because I don't necessarily know what I'm going to need. So I think the time we did it a second ago, we just brought down the next term. I'm letting you know it's okay to bring the rest of it down if you want to. Okay? Because sometimes you will need it. Okay? Now what? Start over, right? Start over. 7x squared divided by x. 7x squared divided by x is just 7x. Where does it go? Oh, see, if we wouldn't have had that, where would we put our 7x? And that would be bad, right? Okay. So what's 7x times x? 7x squared. And 7x times negative 2? And so if I would not have had the 0x term again, I wouldn't have had any place to put the negative 14x, right? Okay, so just try to remember that. And now, subtract. 7x squared minus 7x squared? 0. 0x and 14x. And then, bring down the 4, right? And now, start again. 14x divided by x. 14, now that's right. 14 times x. 14 times negative 2. And now, subtract. Zero. 24. So what's my answer? Questions? What's going to trip you up? Remainder might trip you up sometimes. What else might trip you up? If there's not a term, right, you might forget to put it. What might trip you up? It's like when you subtract, right? That might trip you up. So signs. Okay? So there's a lot of places to trip up, but we are smarter. We can succeed, yes? Take your time when you do these. Can I do another one for you? Is that okay? Okay. Oh, it's crooked. Sorry about that. What goes where? X squared minus 6 goes on the outside. Now, I know that he noticed that there wasn't an x term. Did we add anything here? We did not, and that's okay. Where do we have to make sure to add stuff if there's not something represented? In the box. Okay? You know what I mean, right? There's not an x term here. We didn't have to add anything, and that's fine. Okay? What goes in the box? X to the 4th. 0, x to the 3rd. Okay? Now, someone hasn't talked yet. What do I do first? What do I do first? First term and first term, right? What is x to the 4th divided by x squared? So where does it go? Above the 5, right? Because it's x squared, so I want it to go above its like terms, right? So x squared here. Now what do I do with this x squared? Multiply it by this, what I'm dividing by, right? So it's x squared times x squared. X to the 4th. What's x squared times negative 6? Negative 6x squared. And now, subtract. What's here? What's here? Ooh. What's here? 11x squared. Plus 3x minus 2. I mean, are we okay with that? Yeah. Doesn't that just make our problem easier? Yeah. So did we, in this particular problem, actually need that? We did not, but we still put it anyways because we know for most of the other problems that we need it, so we're just going to put it in there, right? Okay. Now what? Start over. 11x squared divided by x squared. Just 11, right? Where does it go? The 2. Right? Now, before we did this part, if I would have said how many more times might we need to divide? 2, right? Because we had this space and this space. How many more times are we actually dividing? Just the 1, right? That's okay, isn't it? Okay. So what's 11 times x squared? 11x squared. What's 11 times negative 6? Negative 66. And now, subtract. What's this? 0. What's this? 3x. What's this? Plus 64, right? Now what? Do we start again? How do we know we don't start again? There's 2 ways to know. Well, there's more than that, but we'll talk about 2 ways. Yeah, first of all, there's no more room at the top, right? There's no more space. I can't go back and put an answer here. Here's another way to know. If I would do it, I would say what's 3x divided by x squared? Can I divide an x by an x squared? No, this one's bigger, right? I can't divide that in there. So this is my remainder. X squared plus 11 plus 3x plus 64 over x squared minus 6. That is my solution. Questions? We good? Like you're good to go on your homework good? Okay. If you have any questions, what do you do? Ask, absolutely.